Okay, hi everybody. This is Daniel, and I'm going to be explaining how to do number 8. And in this problem, we have somebody called Tyler, and he has a calculator with a display number and 2 buttons, one of which increases the display number by 1, and one of which doubles it. So, now we start with the display number 0, and we randomly press a button with equal probability 8 times. So we kind of just press 8 of these buttons, and given that he pressed each button 4 times, so that means that he pressed the times 1 button 4 times. Sorry, plus 1. Press the plus 1 button 4 times. And then he pressed the times 2 button 4 times. Well, they're asking for the expected value of the final number. Alright, so this problem is a bit tricky. First of all, let's try to see what are all of the different possibilities. Well, you can kind of arrange these plus 1s and these times 2s in any way that you want to. Note that you're starting with 0 and you're kind of just going through this list and doing it one at a time, ignoring order of operations. So really what it's going to look like is, so in this case, if you just did it straight in this order, you would be like 0, 1, 2, 3, 4, and then 8, 16, 32, 64. And this should be the maximum. If we add on all the ones first and then we multiply all of them by 2, that's how we try to get the maximum out of it. And the minimum possible is if we started from 0 and we did times 2, times 2, times 2, times 2, and then plus 1, plus 1, plus 1. And in this case, we note that all the way up to here we are 0. And then from here we go 1, 2, 3, 4. So these are our maximum and minimum right here. So our max is 64 and our minimum is 4. Okay, so now the total number of possibilities that we can do is just 8 choose 4. If we just choose out of 8 spots the 4 spots where the plus 1 goes into, then the total number of possibilities we have is 8 choose 4, which is 70. Now, how do we calculate the expected value of the final number? To do this, we kind of, one way we could do this is we could look at all 70 cases and look at all the different values of the 70 cases. And once we do that, we can kind of just add those together and then just divide by 70. So we could add the 70 different results together and then divide by 70. But this is obviously going to take too long. So let's look right here. How can we comprehend this plus 1, plus 1, plus 1, plus 1, times 2, times 2, times 2, times 2 in a better way? Same thing over here. Why is doing all the pluses first and then doing all the doubles later better than doing all the doubles first and doing all the pluses later? You usually want to put the plus, so what happens to this plus 1 right here? You note that this plus 1 right here, this adds the 1 here, right? But later on, these kind of, how is this 1 that's added here affected? When you add on this plus 1, it kind of just looks like 1 plus 1. And then we can keep doing this. It's going to look like 1 plus 1 plus 1 plus 1. And then we're going to multiply by 2 times 2 times 2 times 2. And so it's going to kind of look like 1 times, if we just distributed it out, we could look at it at like 1 times 2 to the 4 plus another 1 times 2 to the 4 plus another 1 times 2 to the 4 plus another 1 times 2 to the 4. And let's look on this side. We're kind of, over here, we're just multiplying by 2 4 times in a row, and then we add 1 4 times. So over here, the times 2's do not affect these plus 1's at all. So right here, we're kind of just doing 1 plus 1 plus 1 plus 1. And as a result, these plus 1's don't affect each other. The times 2's don't affect the plus 1's at all, and we're just really left with 1 plus, or we could think of this as 1 times 2 to the 0 plus another 1 times 2 to the 0 plus another 1 times 2 to the 0 plus another 1 times 2 to the 0. Well, why are we writing these two powers of 2 here? Because in fact, if we try to do this better, or if we really think about what is going on here, this plus 1 right here, there's 4 2's, there's 4 times 2's after it. So what happens to the plus 1 after 4 times 2's? It's going to turn into a plus 16. So in reality, we have just 4 plus 16's. So if we think of this plus 1, and then we have like these 4 plus 1's, we could have these 4 plus 1's intertwined with these 4 plus 2's. But really, no matter what we do, if this plus 1 comes first, then that means that it's going to become under the effect of all of these times 2's. So we can kind of label this actually. So let's label this one as blue, and then this one, all of these it's affected by all of these. And now let's say we label this one as red. Then this one is affected by all of these, both of these actually, sorry. So it's affected by both of these, and then finally, like let's say this one is teal, and this one is green. These are not going to be affected by any of the plus 2's, right? So since these are not affected by any of the plus 2's, we can kind of just think about this as plus 1. This plus 1 is under the effect of 4 plus 2, so we can think of this as plus 2 to the power of 4. And we can think of this as starting at 0, so 0 plus 2 to the 4 plus another. This one is under the effect of 2 powers of 2, so we can do plus 2 to the power of 2. And then we can add on another one, and this one is under the effect of 3, 1, so it's just going to be plus 2 to the power of 0. There's no times 2's after it. And finally, the last one will be plus another 2 to the power of 0. And if we look at it like this, we actually see that this will turn out to be 22. And that's actually going to be what this expression evaluates to if you start at 0 and you do these in order. You'll get 1, 2, 4, 5. Oh, sorry, this should be 22. So this should be 22 because it's 16 plus 4 plus 1 plus 1. So 1, 2, 4, 5, 10, 20, 21, and then 22. So these two terms, these two things actually match up, because we can look at the number of times 2's that each plus 1 is under the effect of. All right, so you can take a moment to digest this. After you've figured out why this is kind of just working, why you can just think of each plus 1 individually and think of how many times 2's is under the effect of, we can now think of each of the plus 1's individually and look at what kind of, how much it actually just contributes to the sum. So since we have 4 plus, we know here we have 4 plus 1's and we have 4 times 2's. If we look at a single plus 1 and we look at it individually, what's the probability that it comes before all of the times 2's, right? So if it comes before all of the times 2's, that means that if we're like just moving it all around, that plus 1 is going to come before the first, like let's say we labeled these A, B. I'll make this a little more clear. So let's say we have 4 plus 1's. And we have 4 times 2's. And we can label these plus 1's as A, We can label them as A, B, C, D, and we can label these as W, X, Y, and Z. Okay, so for each plus one, we're looking at the number of times two that come after it. So for example, if we just look at this A button, the first A, or the first plus one, well, if we're just looking at this A, what's the probability that it comes before W, X, Y, and Z? Well, think about organizing 5 different letters in an order, and the probability that like some number is going to come first is just 1/5, because each of them has an equal probability of being first. So the probability that this plus 1 comes before all of these times 2's is just going to be 1/5. And this 1/5 is the probability that it's under the effect of all 4 of them. So it should be 1/5 times 2 to the 4. And then what's the probability that it's under the effect of 3 of them? That's the probability it's in the second position. Out of these, when we organize the A, W, X, Y, and Z, the probability that it's in the second position out of these 5. And similarly, just like earlier, it should be 1/5 again, because it's, each of the 5 letters has equal probability of being in the second position. And so this should be 1/5, and in this case, it would be 2 to the 3, because there's 3 of W, X, Y, and Z after it. And we can continue going down on the line, and we actually just get 1/5 multiplied by each of the powers of 2. And finally, we have 1/5 times 2 to the power of 0. If we kind of factor the 1/5 out of this, then we get 1/5 times 2 to the 4 plus 2 to the 3 plus ... plus 2 to the 1, or 2 to the 0, sorry. And this should be equal to, if we just like look at the thing in the denominator, 16 plus 8 plus 4 plus 2 plus 1, this is 1/5 times 31. Now, since it's 1/5 times 31, and we have 4 different plus 1's, we have 4 different plus 1's, so we do the same thing for B, C, and D. And we add all 4 of them together, then we should just get 4 times this 31/5 quantity. For each plus 1, it kind of contributes a 31/5 expected quantity. We can expect each plus 1 to kind of contribute this 31/5 to the total sum. And if we're looking at the total sum altogether, then we can look at the expected value of each. We can add together the 4 different expected values that are contributed, and our final answer is 124/5. So this solution can be phrased in a bit more rigorous terms if you're actually looking at expected value, but you can try doing that on your own. This is kind of just like the intuition behind how to do this problem. Yeah, hope you guys enjoyed.